Hi, we are back for Eccentricity Part 2. We're still looking at Conics Packet 2 right now, page 3, and we've scrolled down to where we left off with these word problems involving eccentricity. You're going to notice in 8, 9, 10, and 11, I wasn't so nice. I've mixed together all 4 different types of conic sections that we've studied, and I didn't necessarily explicitly state which one was which. That's no problem though. Can you look at number 8, see how we're given eccentricity? Just this value here should be enough to know whether it's a circle, ellipse, parabola, or hyperbola. And I'm thinking I see a value that's less than 1 for this one, so less than 1 means ellipse. So keep that in mind as you're doing calculations or as you're finding the equation in this conic section. If it helps to determine orientation, you can sketch these and see that 3, 5 is horizontally away from 1, 5. 1, 5 and 3, 5 make this a horizontally oriented, or a horizontal major axis, I should say. So foci are here. Knowing the 2 foci, I should definitely get the center to use in my numerators for standard form. So right in between 3, 5 and 1, 5, you have 2, 5. It's going to be the center. And that should help with your numerators if you want to start filling out the equation of a conic. So up top, we'll have, I guess the order doesn't really matter because these are being added. So we'll have x minus 2 squared plus, it's an ellipse, y minus 5 squared. And we need some denominators. Equals 1. Here, this is horizontally oriented, so let's put a squared with the x's, and we'll put b squared with the y's for that denominator. And now we've got to figure something out here. So, do we know a and or b and or c? We got to know at least one of them, and we can use the eccentricity to go the full way. Center to focus, we know. Center to focus in our picture looks like it's 1 unit. So c equals little c equals 1. And let's take that to something new, these 2 circled items. Eccentricity, by definition, equals c over a. And here we said c is 1. So 0.25 equals 1 over what number? We'll say a equals 4 here. And now we've got our first numerator. 4 squared can go with the x's, a 16. Now we're looking for b, but as always, if we know a and c, that shouldn't be too much of a problem. So we can use ellipses Pythagorean theorem. So a squared equals b squared plus c squared to finish it off. So 16 is b squared plus, what was c again? Plus 1 squared. So plus 1 will make b squared equal to 15, and that's enough to know our denominator and finish the problem. So 15 is here. Trying to be neater. Maybe I could box this in purple. Here goes nothing. And that is your, nice, that's your standard form equation. All right, let's move right along. Number 9, center at 3, -1, focus at 3, -4. Eccentricity is a value greater than 1. I'm expecting a hyperbola. Getting used to that. C being greater than A for hyperbolas. Is this thing vertically or horizontally oriented? Well, when we sketch it, 3, -1 is here. That's the center. The focus is down vertically from there, right? At 3, -4. So in this equation, we're expecting the y. I'm going to have the y's be the positive fraction. We'll have a y minus something squared over a squared minus x minus something squared over b squared equals 1. And while I'm at it, we were given the center, right? We've got our h and k, so there's no reason not to plug those in right now. Y minus -1, so plus 1, and then x minus 3. Okay, so we need a squared and b squared. Same idea as last time. Here we have center and focus again. So we can do, C is going to be the distance between them. So C and this one is going to be 3 units. Little c equals 3. And then where I have some space over here, this is a hyperbola. We have to shift our thinking. Do the regular Pythagorean theorem. C squared equals a squared plus b squared. So 3 squared equals, I don't have either of those yet. I skipped a step. Let's go eccentricity. So eccentricity is 1.5. That always equals c over a, and we have c is 3. So 1.5 equals 3 over a we'll use. Over a. And I'm going to multiply both sides by a, get 1.5a equals 3, and I need a equals 3 divided by 3 halves. 3 divided by 3 halves should just give me 2. So that should help in this calculation. We'll take this over here now. So 9, c squared, equals a squared plus b squared. And you get b squared should be 5. Okay, so a squared of a 4 can go here. B squared of a 5 can go there. Looking pretty good. We'll box it. And that's your standard form. All right. Looking at 10. Center at 3, 0. All right. Vertical major axis is 12 units long. I can stop dead in my tracks there. If I say major axis, there's only one real conic that has to do with a major axis, and that's an ellipse. The fact that they give us the eccentricity here is essential to the problem, but in terms of classifying and saying, oh, that's less than 1, I know it's an ellipse, it's just icing on the cake. Even just me using that vocabulary indicates that this should be an ellipse. The center's at 3, 0, so we have our numerators and they can go in either order. So I'll just have the x's going first. X minus 3 squared plus, because it's an ellipse, and y minus nothing squared with the 1 on the other side. Now for the rest of it, we need an a squared and a b squared, and I don't even know which goes where at this point until I see a little bit more about it. Well, next word is vertical. Vertical major axis means this ellipse is going to be more elongated vertically. So we'll put vertical whole major is 12 units long. A should be half of that. That means A should be 6. A is the semi-major. So a squared can go with the y's, and a 36 enters the denominator of that fraction. Now let me not skip this step. They must have given us eccentricity for a reason. So 1/2 equals the ratio of C to A is what we learned. And here, what do I have? I have A. 1/2 equals C over 6. Okay, and C should equal 3. And we'll back into it with Pythagorean theorem for ellipses. That's where A squared equals b squared plus c squared. So b squared plus 9, and we'll subtract. B squared here is 27. That's going to go into the fraction. That's our missing link, 27. And I think there's nothing else to do with this one either. So we will, let's make it green. And we'll box it. All right, there is one more at the bottom of the page. And what does it say? Vertical transverse axis is 10 units long. That's a lot of info. Not only do we know whatever this conic section is, it's oriented vertically, focus on the y's, but that word transverse coupled with the fact that eccentricity is greater than 1 leads me to know that this is going to be a hyperbola. I wouldn't use the word transverse otherwise, and the eccentricity being greater than 1 definitely confirms it. That means the center is at 2, 0. Wow, we're given the world here. We've got h and k. That means your y minus k squared, this vertical part here, is going to go first, or be part of the positive fraction is a better way to say it. It's a hyperbola, so we are subtracting in between, and then you have x minus h here. I'll tell you, these are great review questions because we're just shifting our focus back, focus, no pun intended, focus, but back and forth between the different strategies and the different ways you handle all these conic sections. So here's a hyperbola example. Now we got to get a squared and b squared. I think that the eccentricity should help. Ooh, and vertical transverse axis, 10 units long. The whole entire thing is 10 units long, so half of it is going to be a. We'll say that a equals 5. We can put 5 squared with the y's. We'll put a 25 as our first denominator. Now time to get b. So if eccentricity is always c over a, we've got 2 equals c over a, so over 5. And that makes c equal to 10. Hyperbolas use regular Pythagorean theorem. C squared equals a squared plus b squared. C squared is 100. A squared is 25, we said, plus b squared. You get b squared is 75. And there's your missing link. So put a 75 here. I had one more problem that I wanted to squeeze in, but to get to this one, it's part of the homework set. So you got to go all the way past page 4 to the bottom of page 5, the very last question. So you're turning a few pages here. And once you read number 13, would you mind pausing the video and giving it a try on your own? I think this is a better one to brainstorm some ideas for on your own, trying to figure out how you could get the ratio of C to A for this situation in this hyperbola, and then turn the video back on. Let's compare. How's this thing looking? So you have foci that are directly one above the other. At 1, -4, focus, and then up at 1, 6. Okay. So what does that tell us? Well, it tells us in the standard form equation that y's would be part of the positive fraction. It also gives us the center. The center is right in the middle. So center is going to be at 1, 1, I believe, which is equidistant between the two foci. And that gets you, if I'm interested in getting C over A, I'm halfway there because I have the distance from center to focus, right? Or Actually, yeah, center to focus would be C. I'm still missing A, but I have that C in this case is going to be 5 units. All right. If I had A, that would be wonderful. I'm going to start filling in an eccentricity expression. So it's C over A, and C we said is 5. So we need A here. Now think about it. Any other time in our studies that we've seen like a passes through type of question, like it gives us a point, what we generally do is we start writing out an equation, y minus 1 squared over a squared, which I don't know yet, minus x minus 1 squared, we'll say over b squared equals 1. And we do a plug-in, and that's all well and good. But I don't think we need all of that. We're not interested in getting b. We just want to get a here. Well, take a look at what this point is. Do you notice these 3 points have something in common? They all share an x-coordinate 1. Turns out that this was a sneaky problem, and they actually didn't just give us any point. They gave us one of the 2 vertices. One of the 2 vertices falls right along the transverse axis here, and it's at 1, 4. That's awesome. I can see now the distance from center to vertex, A, is going to be 3 units, and I solved the problem without having to do a plug-in. 5/3 is the eccentricity. Are you happy that it's greater than 1? Because I am, right? That confirms that we're dealing with a hyperbola. I hope you guys have a great day, and I'll see you next time.